Hello everyone, and welcome to this quick Blender tutorial where we're going to see how to model this little Play-Doh-like Roman pillar from scratch. By the end of the video, you'll know how to transform Blender's startup cube into this simple shape, thanks to the powers of the bevels of course, but also basic scaling. Okay, so let's hop into Blender, and as usual, to begin with, let's do the same as we did in the previous episodes of the series, and take care of our pivot point. So we'll tab into Edit mode, go in Front View, and with our whole mesh selected, move everything up 1 unit along the vertical Z-axis to place our pivot on the XY plane. Alright, now we need to take care of the base of our pillar. Because here I'm going for a simple aesthetic, I'm going to simply use my cube for the pedestal. More specifically, we can bring down the top face to make the cube flatter, and then inset it and extrude the inserted face to create a second step. And that's it for my base. Of course, if you'd prefer to have a circular pedestal, for example, you could redo the steps, but with a cylinder as the startup mesh. But anyway, now that we have our pillar space, we can super easily make its capital, so the other end, simply by mirroring the pedestal on the other side. So let's duplicate it, move it up some arbitrary amount to determine our pillar's height, and finally rotate it 180 degrees to have it face the other way around. And there we go. This makes for a simple pair of supports that can go with a variety of column types. Now, of course, we're still missing the main part of a pillar, the shaft in the middle that joins those two pieces together. And in this tutorial, I want to discuss how we can easily model 3 designs for this middle part in increasing order of difficulty. The simplest solution is obviously to just stick with cubes and make the shaft itself another stretched hard angle piece. This can totally work for some game environments that feature very minimalistic or very rigid and voluntarily harsh visuals. Plus, let's say that I go in random mode, put some lights in my scene, and give my model a simple sandstone-like material with a high roughness. Then you see that if I reapply the bevel technique that we saw in the previous episodes, with a vertex group-based limit method to pick the edges to smooth, and then I apply an auto-smooth to my object, I can quite quickly improve my simple shape and give it a bit more personality or cuteness. Okay, but suppose that you want to make something slightly more evolved than this, like a round column, for example. Well, let's just duplicate our first model to keep it as a reference, and in this new one, hover our center shaft and press L to select it, then X to delete it. Now, instead of adding a cube, we're going to add a cylinder. In the creation options, I'm also going to reduce the number of vertices to 24, because we don't actually need that much detail, and I still want to keep a multiple of 4 for our future modeling, as you'll see very soon. Now let's just scale and place the column, reapply auto-smoothing, and we're done. We see that our pillar structure readapts super simply to other types of shafts, and we now have 2 versions with varying levels of detail. And yet, of course, this is perhaps still too basic for you. So let's discuss how to transform this second round shaft into a third really cool one with little flutes carved along the surface. So this is where having a number of vertices that is a multiple of 4 will come in handy. Cause let's say that we select this edge, and then we count 3 edges before selecting the next one. If we do this all the way back to the front, you'll see that it matches perfectly the first selected one thanks to this specific number of vertices. And now all we have to do is press S to scale those edges, and then Shift plus Z to limit the scaling to all the axes except the Z one. This way we can easily bring our selected edges inwards and create the flute on the shaft. To improve this effect a bit, we can also apply a manual bevel on those edges by pressing Ctrl plus B and upping the number of segments by 1. This makes the flute slightly more curved, which interacts better with light. And here we are, we've now got a third type of pillar that could look really great in a low poly game or render. Now, just to wrap up this tutorial, let's quickly do a bonus and optional step, which is to modify our final pillar and give it some cracks and dents, just like we did for stairs in the last tutorial, to make our object older, give it a sort of backstory, and typically have it better fit in some ancient ruins, for example. To do this, we'll reuse the same technique as last time, and do some manual bevels on specific edges with Ctrl+B, and vertices with Ctrl+Shift+B, to selectively damage parts of a pillar. Note that there's not really an absolute rule on how to do this, so you should just feel free to try out different things and find a look that you like. But anyway, there you go. You now know how to transform Blender's startup cube into a simple, cute Roman pillar, and with 3 possible variations. I really hope you enjoyed the tutorial and that you learned a few things. If you did, feel free to like the video and subscribe to the channel to not miss the next ones. And of course, if you have other ideas of cool Blender tricks that you'd like to learn, tell me in the comments. As usual, thanks a lot for watching, and take care.